Hello everyone, I'm Yu Rui, CEO of JD Logistics. I'd like to thank the Friends Edelman Award Organizing Committee for giving JD the opportunity to show the development of China's unmanned logistics. The past 10 years have been a decade of rapid development in China's express logistics industry. The express delivery business volume has surged from 3.67 billion units to 83 billion units. In these 10 years, JD.com has transformed from a technology-driven e-commerce company to a technology and service enterprise with supply chain at its core. We established JD Logistics Business Group in order to continuously strengthen the construction of logistics infrastructure, enhance the investment of supply chain and logistics technologies, and drive the industry to optimize logistics costs and operation efficiency. As of the end of 2020, JD Logistics operated over 900 warehouses, with an aggregate floor area of approximately 21 million square meters. Therefore, solving and increasing warehousing efficiency is not only an inevitable challenge for JD Logistics development, but also a priority that must be undertaken as a company committed to social responsibility. The Unmanned warehouse project we shared is a typical solution to improve warehousing efficiency. It has been verified in JD scenarios. It has also opened up commercially to external clients. It does not only contribute to increased efficiency for JD's business, it is self-financing our technology R&D through external revenues. Additionally, it is leading to the digitalized upgrade of the whole supply chain to drive the industry and our business partners to lower costs and increase efficiency. Next, my colleagues will tell you the story behind our Unmanned warehouse project.
Hello everyone, I'm Xiao Jun. I lead the JD Logistics X team, which has researched unmanned logistics projects since 2015, including unmanned warehouses, drone delivery, autonomous delivery vehicles, and so on. I've witnessed the entire development of JD's Unmanned warehouse project. Since starting its e-commerce business in 2004, and its self-built logistics network in 2007, JD has always regarded the promotion of logistics technology development as its core competitiveness. JD Logistics divides warehousing technology into 3 generations. The first generation is manual warehousing, based on manpower. The second generation is automated warehousing, based on electrical equipment. And the third is flexible warehousing, based on robots and digital intelligence. Each generation aims to break through the bottleneck of development during that time. Unmanned warehouse is a typical 3rd-generation warehousing technology. With the in-depth development of online retail in China, consumers' demand for timely delivery have also increased. At the same time, the cost of labor, which is the foundation of e-commerce operation, is also rising. Statistics show that 10 years ago, the labor cost was 1/4 of what it is today, which also caused difficulty in recruiting workers. Therefore, the evolution of warehousing technology aims to find solutions for these problems. However, the pain points solved by technological evolution are slightly different in each era. The evolution from the first generation to the second was to solve the problem that manual work could not achieve high-density storage and high-throughput operations. The second to the third generation evolution, in addition to reducing the human cost, also takes into account the care of employees. For example, the unmanned warehouse can effectively reduce the physical harm to employees in a cold chain environment of -30 degrees Celsius. The technology can even reduce the density of human operations and cut off the transmission route of viruses like COVID-19. JD has always spared no effort to invest in new technology, especially supply chain technology. Since the launch of the Unmanned warehouse project in 2015, JD has invested heavily in talent and R&D. Under this circumstance, Unmanned warehouse technology effectively solves the problems of warehousing efficiency and high costs. Thanks to the application of the operations research algorithm, the whole unmanned warehouse system can operate in an intelligent and efficient way. After our calculation, the effectiveness of unmanned warehousing operation can be reflected in the cost and efficiency data. According to JD.com's 2020 annual report, We have helped the company decrease fulfillment expense ratio to 6.5% and lower the inventory turnover days to 33.3, an industry-leading level in the world. After this technology was applied to JD's internal business, we opened it up to external clients. Commercialization has brought expensive external revenue, which has effectively promoted the further evolution of this technology. Next, my colleague Professor He Qian will explain how we apply the theory into practice for the combination of operations research algorithms and engineering.
Hello everyone, I was a full professor in computer science at the University of Minnesota. Currently, I'm the Vice President of Artificial Intelligence and Data Science at Jingdong Logistics. In 2017, I left the academia field to work in industry area and witness various data science applications in the industry environment. The unmanned warehouse of Jingdong Logistics is undoubtedly a model of integrating industries and research that requires both theory and domain know-how. To my knowledge, there are at least 3 challenges in unmanned warehouse projects. First of all, it's a challenge for our internal algorithm engineers to establish a clear operation research optimization model that combines business experience to describe the robot scheduling problem in the unmanned warehouse. Starting from the actual pain point of problem is the beginning solving the problem. In Jingdong Logistics, I motivate algorithm engineers to dig into actual work, understand the operation rules of the business in depth, and then examine the problems we should solve. Our engineers can now apply theoretical models to solve problems with a good business sense. Second, in a dynamic environment with a continuous flow of incoming orders, solving the current optimal solution may not necessarily be the best choice in the entire operation process. When we solve large-scale optimization problems similar to the unmanned warehouse, it is practically important to make a selective trade-off between both the quality and the speed of the solution. Finally, in the industrial environment, we often face problems that are not paid attention to in academia research. For example, in the communication of robots in the wireless environment may be interrupted in the actual operation of the unmanned warehouse. If we make simplifying assumptions about the dynamics of the robots, we could easily distort the model and make the design out of touch with reality. To find the right balance between the theory and practice, we formed a joint team of industry and academia, and they will share some practice below.
Thank you for the nice summary, Professor Tian He. Hello everyone, my name is Heng Leqin, the head of the algorithm engineers of the Unmanned Warehouse project. Together with 2 professors, we will introduce our robot dispatching algorithm, the brain of the unmanned warehouse system. Let us start with a high-level overview of the problem of interest. In a conventional warehouse system, heavily relying on human labor, workers work along the storage aisles, pick up requested items from storage racks, and return to sort and pack the orders. By contrast, in a modern unmanned warehouse, AGVs pick up storage racks and transport them to workstations, where pickers pick up the items from the racks to fulfill the orders. The 4 pictures on the page represent the panoramic view of unmanned warehouse. AGVs driving into the bottom of racks, AGVs carrying racks, and employees picking at the workstation. They are the most representative elements of unmanned warehouse. To run an efficient unmanned warehouse management system, we aim to effectively dispatch AGVs to racks and workstations in real time, and minimize the operating cost and order fulfillment time. To achieve this goal, we build and solve a complex online matching problem among AGVs, racks, and workstations. At a high level, AGVs are assigned to racks and workstations by using a tripartite network flow paradigm, as demonstrated in this figure. The three components of flow network are 1. AGVs, 2. Racks, and 3. Workstations. We focus only on the scenarios in which an AGV picks up a rack and brings it to a workstation, where some desired SKUs are retrieved. There are two major challenges. First, assigning jobs and matching products with demand of each destination are usually NP-hard optimization problem. The computational time grows exponentially as the size of problem increases. In a typical AGV system, there are thousands of vehicles, products, hundreds of destinations. Second, the matching problem described here must be solved in each operating period because the numbers of idle AGVs, racks, available berths, and inventory of each rack are changing over time in our system. One operating period is less than 5 seconds. Thus, the matching problem must be solved within 3 seconds. It's time to talk about the model. This is a by-criteria optimization problem, where the goal is to minimize the total travel distance of AGVs, subject to constraint that all orders must be met in a timely fashion. Here, the decision variable Xij represents the matching between AGVs and racks. Yjk represents the matching between racks and workstations. Zks represents the unsatisfied demand for SQS in the workstation K. There are many constraints, such as Constraint 1 suggests that each AGV can be assigned to at most one site. Constraint 2 suggests that each site can be picked up by at most one AGV. After we built a model and tried to solve the problem, we quickly found that the problem was not as simple as we thought. So we decided to seek for help from academics.
Let me introduce our solution method. As Henne mentioned, this is a large-scale integer program. Among all the constraints, constraint 4 makes the problem difficult. In particular, this constraint says whenever an AGV is assigned to a rack, the rack must also be assigned to a workstation. Otherwise, if a rack is idle, it should not be assigned to any workstation. We tackle this online matching problem via a Lagrangian relaxation. Specifically, constraint 4 is the only one links the decision variables x and y together. We mainly adopt the idea of divide and conquer and separate the main problem into two smaller subproblems by introducing the Lagrangian multipliers associated with the constraint. By introducing the dual variable lambda, the original problem can be decomposed into two subproblems. Subproblem 1 only involves decision variable x. Subproblem 2 only involves decision variables y and z. Why is the decomposition important? Because subproblem 1 is essentially a linear program, and subproblem 2 is a much smaller integer program. For example, in a typical warehouse with 250 AGVs, 1,800 racks, 50 workstations, and 2,000 SKUs, the original problem has approximately 1 million decision variables and 1 million constraints. After the decomposition, subproblem 1 is still large, but it is an unbalanced assigned problem, which is essentially a linear program. And the size of the integer programming problem 2 reduced significantly, approximately by 75%. The linear program can be efficiently solved by the Hungarian algorithm or primal dual-based algorithm. Although problem 2 is much smaller, it is still a non-trivial integer program to solve. We apply a cutting product method to one of the constraints, which causes all the problems. This constraint essentially says We can use different inventory on different racks to meet certain demands, because the same product can be located in many different racks. These constraints essentially correspond to set covering style constraints that couples the decision variables in a way making the constraint matrix lose total modularity. We have applied different types of cuts, including lifting cuts and minimum cover cuts. It is important to emphasize, adding cuts does not guarantee an integer solution by solving the relaxed problem. The purpose of adding these cuts is to enhance the quality of the solution derived from the relaxed problem, namely to achieve a better outcome after the rounding procedure. We also found that even a smaller number of cuts is sufficient to find a high-quality solution. Another key issue is to find a good value for the dual variable lambda. We solve the continuous relaxation of the original problem to get a good approximation. We note that it is not fast enough to solve the continuous relaxation of the problem every 5 seconds. Fortunately, it is not necessary to update the dual variable frequently. Finally, we adopt the pre-processing procedure to reduce the problem size before solving the relaxed problem. For instance, if a rack is far away from a workstation and its inventory is not sufficient to satisfy the given demand, we may simply eliminate this rack. Combining all together, we are able to find near optimal assignments for hundreds of AGVs in seconds.
To demonstrate the efficiency of our algorithm, we compare it with the algorithm solving the original MIP formulation by CPLEX, one of the most powerful MIP solvers. For simplicity, we call this algorithm the CPLEX solver method. Note that the CPLEX solver method may not find the exact optimal solution in a reasonable amount of time. Thus, we set a limit on the computing time for the CPLEX solver at 30 minutes and 60 minutes respectively. The solver will stop and return the current best feasible solution by the deadline. Let us look at the computing time. Our decomposition method always solves the problem within 3 seconds for all the cases. By contrast, the CPLEX solver method is much slower. Regarding the quality of the solution, let us look at the relative gap. A positive gap ratio means that the CPLEX solver is better, and a negative value means our method is better. When the problem size is small or medium, the CPLEX solver can find a better solution than ours while requiring longer time. However, the gap ratio is less than 17% or smaller. In practice, such a gap ratio is negligible and does not affect the overall performance of the dispatching system. When the problem size is larger, for example in the last 4 rows in table 5, our method performs better. The CPLEX method improves when we relax time limit to 60 minutes. Check the table 6, but still worse than ours. In conclusion, our method can return quality solution within seconds. To conduct an apple-to-apple comparison, JD.com organized 2 real-life stress tests to directly compare a fully mounted warehouse with a conventional warehouse relying on human labor. Both tests took place on November 11, 2017 in Nanxiaoying and Guan, somewhere near Beijing. November 11, also called Double 11, is the most important annual promotion day in China. The findings of these 2 cases are summarized in Table 1 and Table 2, suggesting that the improvement by full automation is dramatic by all relevant metrics. For the Nanxiaoying test, the ratios of number of processed orders, processed items per hour per workstation, the number of processed items per hour per worker, and the number of processed items per square feet were 2.3, 2.4, 1.3, and 1.5 times respectively. The improvement was even more significant in the Guan test. This comes from many reasons, such as SKU types, the size and layout of the warehouse, and the work proficiency. Due to the success of the stress test, JD.com later unveiled a warehouse that can handle 200,000 orders a day, but employs just 4 people, whose jobs are centered around supervising the AGVs. Optimization combined with modern robotics technology results in tremendous improvements in picking efficiency and warehouse space utilization. These numbers exhibit the capacities of our automated system. It can support more than 100,000 merchandise goods, more than 120,000 racks, more than 200 workstations, and scheduling up to 1,000 robots. The model at a size of 10 million can be solved in 2 seconds.
Hello everyone, I'm Liu Shuqing. I'm the director of JD Logistics' Unmanned Warehouse System. Let me introduce the Unmanned Warehouse System below. It is composed of a production integration layer, intelligent scheduling layer, and an equipment control layer. The characteristics of a large warehouse include diversified goods, strong timeliness, high short-term concurrency, and so on. Through the intelligent scheduling algorithm, we optimize the storage, order batch, robot scheduling, and other technological processes to achieve efficient operation and intelligent management. In the process of system construction, we have solved 2 problems by innovation. The first was solving the problem of multi-robot communication efficiency. When encountering a large-scale and high communication load, the request can easily be converted into the object needed by ACA using NETI synchronization non-blocking mode and zero-copy processing mechanism. For each device terminal, ACA creates an actor and runs independently. The actor quickly analyzes messages from corresponding devices to solve communication delay in high concurrency scenarios. When a message in actor handles an exception, the message enters the exception queue. By retrying the communication interruption problem can be compensated for efficiently, and the communication volume processed by the system can reach nearly 1 million messages per second. The second is to solve the problem of massive order production through the intelligent scheduling system. In order to reduce the computational scale and complexity, we pre-process the shelf, inventory data, map location, workstation slot, cache location, car resources, and order data. Then the information system calls the solver to solve the pre-processed data. Through the distributed locking mechanism provided by the token service, the information system supports multi-area and multi-map parallel computing to improve the efficiency and the scheduling calculation. Hello everyone, I'm Jade Wang, Vice President of JD.com and the head of Open Platform for Smart Supply Chain at JD Logistics. Next, let me introduce the process of opening up to external clients. In 2007, JD.com began to build its own logistics network. In April 2017, JD.com announced the establishment of JD Logistics Business Group. Since then, JD Logistics has begun its journey for opening up. That means, in addition to improving our own operations as a supply chain and logistics service provider, we began to provide integrated smart warehousing solutions to external logistics clients. At the end of 2018, when the technology was verified at JD Logistics, we decided to commercialize it and make it available to external clients. We believe that this verified JD incubated technology can essentially solve the efficiency and cost problem of warehousing in the logistics industry. JD is also willing to share its internal practical experiences with industry partners to create greater social value. So far, we have achieved a great result. The project has built its own brand image in over 100 opening up programs across industries, including 3C, apparel, industrial products, education, FMCG, retail, automotive, fresh produce, and manufacturing, facilitating the optimization of warehousing and replenishment. The Unmanned warehouse project has helped JD Logistics earn significant external income, which further drives the company's internal technology development and promotion. I've invited one employee from JD Logistics and one from our external client to talk with us today about the changes brought to them by the Unmanned warehouse project.
Hello everyone, I'm Fanya Wen. I'm a frontline employee working at JD's Beijing Asia #1 Logistics Park. This is my 5th year with JD. I used to work in the manual operation era, and I was transferred to the unmanned warehousing era 2 years ago. When I was working at the manual operation era, I had to walk at least 50,000 to 60,000 steps a day, which made my feet sore and tired. Now it only takes a few thousand or even a few hundred steps a day, which is very easy, and my working efficiency has improved a lot. The working condition of other positions such as sorting, inventory management, and the assembly line have also changed for the better. I am a woman, which in some manual labor scenarios might put me at a disadvantage, but thanks to the unmanned warehouse, I can do almost all the work. I'm very interested in new technologies and new things. When I think about the robots and various automated equipment, I feel like they are my colleagues. We also have learned many skills. We can fix some common problems with the robots by ourselves. Also, we have a general understanding of the overall operation of the unmanned warehouse and can be competent across multiple positions. Each of us have personally experienced the huge changes brought by unmanned warehouses. We are very grateful to the company for making our job easier and hope that the company will develop better and better. Hello everyone, I am Colin Shang, the Deputy General Manager of Yunnan Publishing Group Logistics Company Limited, which was established in November 2017. It is a specialized company responsible for the management and operation of the logistics system of Yunnan Publishing Group. The company is carrying out technological upgrades in order to undergo digital transformation. The goal is to facilitate the online and offline integration of the Yunnan Xinhua bookstore. Our logistics business used to be quite labor-intensive. The process of inbound and outbound warehousing, storing, sorting and picking, and delivery were many done manually. We had very limited automatic equipment, and the working efficiency was quite low and labor-consuming. It resulted in the inefficient operation of the entire logistics system. Fortunately, the adoption of big data, automated equipment, and intelligent management was imminent. In 2020, our company put in to use a modern logistics center for the company's e-commerce business with the target of being customer-centric, efficiency-oriented, quality-focused, and cost-reducing. This initiated the construction of Yunnan Publishing Group's logistics system with JD Logistics' help as a system integrator of the project. JD Logistics leveraged its experience in integrating internet technologies with smart logistics, combining the business development requirements of our company and applied the most advanced automated logistics equipment. With the application of robots for high-density storage and high-speed sorting equipment, which are enabled by big data and intelligent algorithms, the logistics center's efficiency had been improved greatly in warehousing and distribution integration, intelligent dispatching of the order fulfillment system, and automatic production. In the future, the two companies will continue to join hands to lead in-depth cooperation on third-party and fourth-party logistics.
Thank you to our clients, whose voices are much valued. Their experience is the best testimonial for the effectiveness of our unmanned warehouse operations. In the past, taking customer first as its core value, JD.com pioneered the 211 program, same-day delivery service, which has become the new standard of B2C e-commerce service in China. This enables our consumers to enjoy a groundbreaking service to receive orders on the same day they are placed. The 211 program, initiated 10 years ago in 6 cities, has been expanded to over 200 cities in China. And the intelligent logistics infrastructure, including our unmanned warehouses technology, has provided key support for the effective operation of such services. My colleagues have outlined the development process of JD's unmanned warehouse project. It is also a profile of the overall development of JD.com, reflecting the company's mission to be powered by technology for a more productive and sustainable world. Next, I will once again share and emphasize some key figures of the unmanned warehouse project. First, we have seen a significant effect of the project in lowering warehousing costs and increasing operation efficiency. JD is now operating over 900 warehouses, in which unmanned warehouses algorithms are largely applied. Some of our unmanned warehouses can process more than 1.3 million orders per day during peak seasons. Overall, while serving 470 million customers of JD.com, we are able to lower the inventory turnover days to 33.3 and to decrease fulfillment expense ratio to 6.5%, an industry-leading level of operation efficiency. At the same time, 90% of JD.com's first-party retail orders in 2020 were delivered the same or next day after they were placed, again raising the bar in customer experience for the industry. Second, we have been able to open up unmanned warehouse technology to external clients. We formed integrated supply chain solutions, including the Unmanned Warehouse project, that have been opened up to multiple industries such as FMCG, apparel, home appliances, home furniture, 3C, automotive, and fresh produce. In 2020, JD's logistics business served more than 190,000 corporate customers. In addition, unmanned warehouses have also contributed to greater social responsibility, such as improved labor conditions and environmental protection. With the increasing development of China's online retail industry, the products that an unmanned warehouse can handle has expanded from the original 3C, daily necessities, books and other normal temperature storage categories to fresh produce, medicines and other categories that require special temperature storage. We are exploring a cold chain unmanned warehouse which could effectively lower the harm to employees working in cold environments through automation. The COVID-19 pandemic has challenged the operation of traditional warehouses since the beginning of 2020. Thanks to its highly automated model, JD's unmanned warehouses were able to maintain normal operation during this period. In this global battle against the virus, our unmanned warehouses do not only operate normally to ensure the supply of necessities to customers across China, it also shows a sustainable warehousing model for the future that is green, healthy, and highly advanced and productive. Technology is the biggest driving force for industrial transformation and enterprise development. JD.com cherishes the experience of participating in the final round of competition for the France Edelman Award, and we've added it as a highlight in our earnings report released earlier in March. As the CEO of JD Logistics, I once again recommend JD's Unmanned Warehouse project to you and hope our achievements are recognized in the competition. Thank you for your patience watching our video. Thank you.